Welcome back to Analytic Geometry. This is our first lesson on ellipse. An ellipse is a set of points such that the sum of their distances from two fixed points is constant. The two fixed points this definition refers to are the foci. So this is what the definition wishes to tell us. Given an ellipse, let us locate point P. That point has a distance from one focus, and that is given by the length of the line segment PF1. It also has a distance from the other focus, and that distance is given by the length of the line segment PF2. The sum of those two distances is equal to a constant. Let us call that constant 2 times A. Now, this is what the definition wishes to tell us. If you were to locate another point on your ellipse, let's say, for example, point Q, okay, let us get this length, its distance from one focus and its distance from another focus. Well, guess what? The sum of those two distances is also equal to this constant. 2 times A is also the length of the line segment that joins the two vertices. V1 and V2 are the vertices, and the length of that line segment is equal to 2 times A. I wrote a book in pre-calculus some 6 years ago, and when I was describing this, the distances or the length of the line segments, this was the notation that I used. But I am changing that now. When we are talking about length of line segments, let's say, for example, the length of the line segment that connects the two vertices, this is how we write it. V1, V2 is equal to 2A. We are referring to the length of the line segment. But when we are referring only to the line segment itself, that is how we ought to write it. V1, V2, those are the endpoints, and then we will draw an accent at the top, a line segment at the top. This is how I will write it when I produce the second edition of my pre-calculus book. It has a center, and that center is the midpoint of the line segment that connects the foci, but it is also the midpoint of the line segment that connects the two vertices. V1 and V2 are the vertices, and the line through the vertices is what we call the principal axis. The principal axis will tell us the orientation of our ellipse. The principal axis can be horizontal, it can be vertical. So when it is horizontal, you can imagine an ellipse that seems to be lying on a bed. When the principal axis is vertical, it's going to be an ellipse that seems to be standing up. The major axis is the line segment that connects the two vertices. The minor axis is the perpendicular bisector of your major axis. We also have such a thing as the lattice rectum. We first met the lattice rectum from parabola. The lattice rectum will tell us the focal width of our parabola. It's the width of your parabola along the focus. So the same information is given by the lattice rectum of your ellipse. So it is a line segment. It is a chord that is perpendicular to your principal axis and perpendicular at the focus, or the point of intersection is the focus. So the length of your lattice rectum will tell you how wide or how narrow your ellipse is along the focus. A larger lattice rectum will give you a wider ellipse along the focus. A shorter lattice rectum will give you a narrower ellipse along the focus. Now, when we are sketching our ellipse, we will not pay attention to the lattice rectum. We will pay attention only to the vertices V1 and V2 and to the endpoints of your minor axis. And given those 4 points, we will trace a smooth ellipse. Standard equation of an ellipse. This is the standard equation of an ellipse when the principal axis is horizontal. Something like this. The principal axis is horizontal, and so we can describe the ellipse to be something that is lying down. Now here, okay, a squared is always greater than b squared. So when you look at the standard equation, you have numbers in the denominator. Whichever is bigger, that is a squared. Okay? C squared is equal to a squared minus b squared. And C will help us locate the focus of your ellipse. The center is given by HK. This is how we locate the focus. So the focus, the center, and the vertices, they are collinear. They all lie in the principal axis, which in this case is horizontal. So what we do is we obtain C. And then from the center, okay, HK, we measure C to the left. That will give you one focus. We measure C to the right. Okay, we plot that point. That would be another focus. The vertices. So again, the focus or the foci, the vertices, and the center, they are all collinear. They lie in the principal axis. Since the principal axis is horizontal, and let's say, for example, this is our center. To locate the vertices, we pay attention to A. We get the square root of A squared. And so we measure A to the right of your center. That will give you one vertex. Okay, look at this. And we measure another A to the left of your center. That will give you another vertex. We have another set of equations, standard equations, for the case when the principal axis is vertical. So the ellipse would seem to be something that is standing up. This is the equation. And again, a squared is greater than b squared. It can be confusing recognizing which equation goes for the principal axis that is vertical and which goes for the principal axis that is horizontal. So what you do is you pay attention to the larger denominator. When it is under y, the principal axis is vertical. When it is under x, the principal axis is horizontal. Again, the center is HK. The center, the vertices, and the foci are collinear. Since the principal axis is vertical, to locate the foci, we begin from the center and then we move up or we move down. We measure C. The location of your foci will come from C. You add C vertically or you subtract C vertically, plot the point, that will give you the foci. To locate the vertices, we pay attention to A. The A here, will help you locate the vertices. Since the principal axis is vertical, starting from the center, you measure A units upward and measure A units downward. That will give you the location of your vertices. Given the equation of an ellipse in standard form, this is our equation. We shall locate the center. We will describe the principal axis, locate the vertex, locate the endpoints of the minor axis, and sketch the ellipse. So this one has a center which is at the origin. Okay? 0, 0. Now, let us pay attention to the denominators. Okay? Whichever is larger, that's going to be a squared. So a squared is equal to 9. And it is under x. It is under x squared. This means our principal axis is horizontal. We will locate now the vertex. A will help us locate the vertex. A is equal to the square root of 9, which is equal to 3. So we will measure 3 units to the left and to the right of your center. We plot the point that will give us the vertices of your ellipse. Okay? So that is one vertex. 0 minus 3. Okay, that's why it became negative 3. And then the other one is going to be, 0 plus 3. 0 coming from the center, you add 3 to the right. That will give you another vertex. Locate the endpoints of the minor axis. It's B that's going to help you locate the endpoints of your minor axis. So here, B squared is equal to 4. This means B is equal to 2. So we will count 2 from the center going up and 2 from the center going down. That will give you the endpoints of the minor axis. And then we will trace a smooth ellipse.